Now let me introduce you what exactly we mean by determinant. To every square matrix, say A equal to Aij n by n, that is of order n, we can associate a number, real or complex, called the determinant of the squared matrix A, and is denoted by this symbol determinant A, like you use modulus A. Now for example, if A is a matrix of first order, say A 1 by 1, then the value of determinant A will be A only. Now example 2, suppose it is a second order. A is a matrix of second order, that is A11, A12, A21, A22. Then determinant A, first write it under determinant symbol, A11, A12, A21, A22. So what is the value of determinant? To evaluate it, first you multiply the elements of the main diagonal, that is A11 into A22, and minus the product of the elements in the other diagonal, that is A21 into A12. For example, if we are given a matrix A as 2 minus 1 and 3, 4, then how do you evaluate the corresponding determinant? We first write determinant A equal to determinant symbol 2 minus 1, 3, 4, multiply the elements on the first diagonal, on the main diagonal 2, 4, 8, minus on the other diagonal minus 3, so 8 minus plus 3, the value of determinant is 11. So that's how you evaluate the determinant of first order and second order. And now the third one, which is very important in the process, how to evaluate the value of a determinant of third order. Evaluate the determinant of third order. That is, directly now I am writing determinant A as a determinant A of third order using the symbol for the elements as we have used in general for a matrix of third order, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. Now how to evaluate? Now please note that we can expand determinant, this determinant A, we can expand with respect to or along any one row or column by multiplying each element of that particular row or column, delete the element through that, delete the row and column through that particular element, and multiply with the rest of the determinant of second order, and take a proper sign along with every element. What do you mean by proper sign? Let me tell you about proper sign. The sign are assigned, the convention is minus 1 to the power I plus j. Look here. For example, here you have 1, 1. So minus 1 to the power 1 plus 1, 2. Minus 1 to the power 1 plus 1, that is 2, so minus 1 square will be what? Plus 1. So we'll take plus. And then minus 1 to the power 1 plus 2 will make it 3. So it will be negative. So you find it will be negative. Then with 1, 3, it will be, see 1 plus 3, 4. So minus 1 to the power 4 will make it positive. So you will find that the signs to be allotted before each element to evaluate the value of determinant will be plus, minus, plus, minus, plus, minus, plus, minus, plus. That the elements on the main diagonal and the other diagonals will remain positive and the 4 in the middle will remain negative. Now let me expand it with respect to first row. Let us expand or evaluate the determinant A of third order along R1. So we'll take the elements of R1, that is A11, multiply it, and of course the sign before A11 we'll take positive, and delete the row and column through A11. Delete the row and column through A11. Then what is the rest of the determinant? The rest of the determinant left is A22, A23, A32, and A33. And of course, this you can evaluate as A11 as such. How do you evaluate the value of the second order determinant? You know the procedure. Multiply the elements on the main diagonal and minus the other diagonal, and the product of the elements on the other diagonal. So we take A11 times the determinant of second order obtained by deleting the row and column through A11, then minus times. You know that we have alternate plus minus, plus minus plus. So minus times the second element of the first row is A12. Again you delete the rows and column through A12. So what do you get by deleting the elements through A12? You get A21 delete the row and the rows and column through A12. So then you are left with what? A21, A21, A23, then A31 and A33. And you can of course work out the value of this determinant, multiply the elements on the main diagonal minus the other. And plus, what will be the third term here? What is the third element in the first row? A13 times the same procedure, delete the row and column through A13, and you will left with A21 and A22, and elements in the second row will be A31 and A32. So in the second step you have A11 times the value of this determinant minus A12 times the value of this determinant and plus A13 times the value of third determinant of second order. So how do you evaluate the value of determinant of third order? We expand it first of all with respect to any one row or column by multiplying each element of when we are expanding it with R1. So multiply each element of R1 with a proper sign, delete the row and column through it, and then multiply with the determinant of second order obtained by deleting the row and column through it. So let me take an example of third order. Take an example. Say here directly I am writing determinant of third order. For example, you have 3 minus 2, 3, 4, 2, 1, minus 1, 4, minus 3, 2. You know the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. So let me expand it with R1. So you take the first element of R1, that is 3, positive 3 of course, with plus sign. Eliminate the row and column, delete the row and column through this A11 or 3. So you left with 1, minus 3, 2. And minus time the second